Now let's talk about negative exponents and scientific notation for small numbers. So if you do a number in the calculator with a bunch of zeros after the zeros, so let's say 0.000003 times the same thing, 0.000003. This calculator is going to give you 9 to the negative 12. 9 to the negative 12. On this one, 0.000003 times this one says 9e to the negative 12. So, so that 9, so that's the same as saying 9 times 10 to the negative 12. And whenever you write that out, it's moving this decimal over 12 times. So let's do that. So let's do 9, 1, 2, 3, 5, 6, 7, 10, 11, 12. So your decimal will be here. Okay, so that's what that number is. It's a ton of zeros. So whenever you have a positive number, like 9.1 times 10 to the 12, you're moving this over to the right. So with a negative number, you go left. And one thing that you can do is, let's say you're dividing exponents. So say you have 10 to the 5 divided by 10 to the 3. So that equals 10 times 10 times 10, 5 times, divided by 10 3 times. You cross out the same amount, so that gives you 10 2 times. And it's the same as just saying 5, doing your 5 minus 3. It's simpler to do it that way, but you can also draw it out if that helps you. So now let's do 10 to the 2 and 10 to the 2, which we know that's 10 times 10 over 10 times 10. All of this crosses out. Gives you 10 to the 0 equals 1, because these are the same on top and bottom. So anything to the 0, when you subtract these, if it gives you 0, your answer is always going to be equal to 1. That's very important if you're dividing. So now let's do 10 to the 3 over 10 to the 6. So this one's going to give us a negative. So 10 times 10 times 10, and 6 times 4, 5, 6. So we can cross out 3 on top, 3 on bottom. So that's going to give us 1 over 10 to the 3, which is the same as 10 to the negative 3. So whenever you subtract these two numbers, 3 minus 6, that gives you negative 3. So if you have a negative number up here, it's going to be like a reciprocal, but with the exponent positive. So if you have 10 to the negative 4, that's going to be the same as 1 over 10 to the 4. So that's also an important thing that you'll want to know. So let's do an example. So let's say 3 to the 0. So earlier I said anything to the 0 is going to be equal to 1. And let's do 3 to the negative 3. And like I did earlier here, we're not using tens this time, but it's the same concept. So you do a reciprocal, because this is negative, and make your 3 positive, your exponent positive. And then the last one, we will use a 10. So let's do 10 to the negative 4, which is the same as 1 over 10 to the 4, which is the same as 1 over, it's going to be 10 4 times, right? Let's see, sorry. 1 over 10,000, right? So we want 4 zeros, so that's a 4. And if you do that, it's going to be the same as 0. So if you do it in the calculator, it'll say 1 times 10 to the negative 4, which is the same if you move the 0 over 4 times, right? So 0.123. So our 1 takes that 4th place. All right. So let's do a different number. Let's do a decimal point, like scientific notation. Let's say we have 3.42 times 10 to the negative 3. So that's going to be the same as 3.42 times 1 over 10 to the 3. So we're going to move this over to the left 3 times. 1, 2, 3. So that's going to give us 0.12342. So the numbers are the same, but we're just moving everything over to the left. And our third number is the first number that we have. So it may seem like we want to do 3 zeros, but we're just doing 2. So we're doing one number less because of that number in there that's greater than 0. If it was 0.42, you would have 3 zeros, but you'd still be using that 0 that was first. And so we saw already with scientific notation that if you do the similar number, you know, where it's positive, you move it over, this decimal over to the right 6 times. And these two numbers are already taking the place of some of the zeros, so we're just filling in 4 more because we already have 2 numbers. So this would be 2, 4, 6, 1, 2, 3, 4, which would give us this number in standard notation. So if we do that same thing but do it negative, 10 to the negative 6. So we're really moving this over 5, or adding 5 zeros, because that 2 takes the place of 1 0. So 1, 2, 3, 4, 5. And then we'll have a 0 before that. So this is going to be 0.234. Ooh, I didn't move 1, 3, 4. There's one more there. 5. And then 6 is going to be 2, 4, 6. So it's a little bit different, but not much. So for negative, we're going left. For positive, we're going right. So let's do an example. Let's write 2.31 times 10 to the negative 5 in standard notation. So we know we need to move this to the left 5 times this decimal. So we have the place of one number, so 2, 3, 4, 5. So you're only adding 4 zeros here. So standard notation 1, 2, 3, 4. Fifth number is 2, 3, 1. That's going to be your standard notation, moving that over. Now let's do another example where we write 0.1, 2, 3, 5. Oh, what happened to that? That's weird. Okay, let's do 55. 55 in scientific notation. So that means we want the 10 number. So for this, we want to move this 0 in front of one of the whole, a number that's greater than 0. So we're going to move this over 1, 2, 3, 4, 5, 6, 7 times. So our number is now going to be 5.5 times 10 to the negative 7. So, and it's the same thing if you want to go backwards and check your work. You want to make sure you have six zeros, because the 5 is going to be your 7th. 1, 2, 3, 4, 5, 6. You want to make sure that this number is the same as the first number. But that's how you write in scientific notation with negative. So now let's do a comparison example. So let's compare 0, and let's find out if it's greater than, equal to, or less than 1 times 10 to the negative 4. So 1 times 10 to the negative 4 is going to move that over 3 times, because the 1 is going to take the place of the fourth number. So 1, 2, 3, 4. So is 0 less than, equal to, or greater than? It's not equal to, because they're not the same number. And so 0 is not greater than, because 0 on the number line, it's still less than this. So this is going to be greater than, because it's still a positive number on the number line. It's really tiny and close to 0, but it's not 0. So that's pretty much everything for this. All right.